Graph the system of inequalities. The first inequality is x is greater than or equal to 9 plus 3y, and the second one is y is less than or equal to 9 minus 3x. So what does it mean to graph a system of inequalities? Well, what we want to do is to find all the ordered pairs in the plane that satisfy both of these inequalities simultaneously. So to illustrate that idea, let's start by picking a test point. I'm going to pick a point that's easy to check, the point 0, 0. So 0, 0 is a test point. Let's check and see if the first inequality is satisfied. We substitute 0 for x and 0 for y, and we get the inequality 0 is greater than or equal to 9, which is a false statement. If we substitute the test point into the second inequality, we get 0 is less than or equal to 9 minus 3 times 0. 0 is less than or equal to 9. This is a true statement. Well, in order for an ordered pair to be a solution to the system, it has to satisfy both inequalities simultaneously. So although 0, 0 satisfies the second inequality, it does not satisfy the first, and therefore 0, 0 is not a solution to the system. Now we could just pick points at random and substitute them in to see if they satisfy the inequality, but that would be a long and laborious process, and we're expecting that there will be infinitely many different solutions. So we want to go about this in a little bit more systematic method. Let's first of all graph the inequality x is greater than or equal to 9 plus 3y. So x is greater than or equal to 9 plus 3y. Let's first of all determine where x is equal to 9 plus 3y. And we recognize that this is a linear equation, so the graph will be a line. One technique for graphing the line is to find its intercepts. To find the x-intercept, we let y be 0 and then solve for x. When y is 0, we get 3 times 0 is 0, and 0 plus 9 is 9. The x value is 9. So the x-intercept of the line is 9, 0. In order to find the y-intercept, we let x be 0 and then solve for y. So we end up with 0 is equal to 9 plus 3y. Take away 9 from both sides. That gives us minus 9 is equal to 3y. And then divide both sides by 3. Y is equal to negative 3. So the y-intercept is 0, negative 3. Let's go ahead and graph this line. Have 9, 0 and 0, negative 3. And then we'll draw the line that goes through this, and we'll use a solid line because our inequality includes an equal symbol. And notice that this line divides the plane into two half planes. We have the half plane below and the half plane above. Before we go back to the inequality, let's go ahead and do the same thing for the second inequality. We have have y is less than or equal to 9 minus 3x. So what we'll do first of all is to graph the line y is equal to 9 minus 3x. So we'll make a table of values like we did before. When x is equal to 0, we can see that the y value is 9, so the y-intercept is 9. When y is equal to 0, we get the equation 0 is equal to 9 minus 3x. Add 3x to both sides. 3x is equal to 9. Divide both sides by 3. X is equal to 3. So this line has a y-intercept at the point 0, 9, and x-intercept at the point 3, 0. So we draw the line that goes through both of those points. All right, and what we notice now is that our two lines have divided the plane into 4 regions. If we like, we could label this, well, we have region 1, region 1, region 2, region 3, and region 4. Alright, what we need to do is to determine which of these regions contains points that satisfy both of the inequalities. So let's start off with our inequality x is greater than or equal to 9 plus 3y. We saw that the point 0, 0 does not satisfy that inequality. So we want to make sure that we include the regions that do not include the point 0, 0. So we're looking at the blue line. The half plane that does not include 0, 0 contains regions 3 and regions 4. And now let's take a look at the inequality y is less than or equal to 9 minus 3x. The point 0, 0 does satisfy that inequality, so we want the half plane that includes the point 0, 0. So we look at our purple line, and the half plane that includes 0, 0 is the half plane below, which includes region 2 and region 3. So which region satisfies both inequalities? Well, we see that that's region 3, and so when we graph the solution or graph the system of inequalities, we want to shade in this region only. So the solution to our system is this region, region 3.